So looking at the second equation here, where I've got sine 2x equal to cosine x, if I go ahead and try to set this equal to 0, I can't factor. Looking there, you should recognize that as the double angle identity, so I'm going to replace that with the double angle identity. And I'm going to go through and factor out the cosine x. Now, some people would have gone from here and put in the double angle identity and then been tempted to divide through by the cosine, but if you do that, you lose a solution. That's why you want to set it equal to 0, factor, and solve, then I don't lose that solution. So now I'm going to use the zero product property. So when is cosine equal to 0? And when is 2 sine x minus 1 equal to 0? So I'm going to look at my unit circle. And cosine is 0 at pi over 2 and 3 pi over 2. And then when is sine a half? Sine is a half at pi over 6 and 5 pi over 6. Again, you could have used the inverse trig functions for this. If you would have done inverse trig of 0, you would have gotten the 90 degrees, which would have given you this one answer, but not this one. And if you would have done the inverse of 1/2, you would have gotten the 30 degrees, but you wouldn't have got the second answer. So now that I take those 4 answers, they want all solutions, so I have to add. So x will equal pi over 2 plus 2 pi k. X will equal 3 pi over 2 plus 2 pi k. X will equal pi over 6 plus 2 pi k. X will equal to 5 pi over 6 plus 2 pi k, where k is an integer. So I'm going to go to Desmos again, and I'm going to put in the original left-hand side equation, which was sine of 2x, and then the original right-hand side of the equation, which was cosine x. And I can look here, turn that off. Here's pi over 6, pi over 2, 5 pi over 6, 3 pi over 2, and you can see the answers, and then you just add the fundamental period to get all your solutions. So let's go back to this second one now. And when I'm looking at the second one, the problem I see there is I've got sines, but my angles are different. So on this one, I'm going to put in the half angle formula. So I've got sine squared alpha equal to 2, and then the half angle formula is going to be 1/2 1 minus cosine alpha. So now I have my angles the same. So I have sine squared alpha equal to 1 minus cosine alpha. So now I've got a new problem. I've got a sine squared and a cosine, so I can use the Pythagorean identity there and replace that with cosine squared alpha. And now I'm going to set this equal to 0. So I'm going to bring the cosine squared over. The ones just cancel. And now I'm going to factor. And I switched randomly from alphas to x's. So let me make these alphas again. So I've got cosine alpha minus 1. So again, the zero product property. So when is cosine equal to 0? And when is cosine equal to 1? So if I come up here to the unit circle and I look at my unit circle, I know that cosine is 0. Again, pi over 2 and 3 pi over 2. Those two angles will give me cosine 0, and cosine is 1. at 0. So those are my 3 answers in one wrap, and if I wanted all solutions, I'd take 0 and add a 2 pi in, so I don't even need the 0. I have pi over 2 plus, now if you notice these guys are repeating every pi, so you could actually put a pi in if you wanted to and have one equation, or you could take both of these and add a 2 pi in, where n is an integer. And I can check that equation as well. You can do this on the graphing calculator. It's just with the Desmos, I find it easier because it gives me the points and I don't have to go through. So then this is 2 sine x divided by 2, and that is squared. So when I look, here's the one answer, second answer, third answer, and then that's 1 period. So we've gone through these 3 examples.